Dear students, in today's lesson we'll learn about test in organic chemistry. So test in organic chemistry means basically the difference, how do you distinguish between the two organic compounds. There are different tests, okay? So we'll discuss this today. So first is the test for unsaturation. Number one, test for unsaturation. Test for unsaturation means if we have an unsaturated organic molecule, unsaturated means either it has a double or triple bond in addition to single bond. Okay. So if the molecule has double or triple bond, so what is the chemical test that will distinguish it? Okay. So the test is, we call it bromine water test. So the test is bromine water test. So when bromine is mixed with unsaturated compounds, for example, this 2, when it is mixed with bromine, okay, now remember the bromine has the reddish brown color. Okay, so reddish brown color. So we have to take the few ml of this one unsaturated compounds and we have to add a few drops of bromine water. Okay, so it has a reddish brown color. If it decolorize, if the bromine decolorize, that means if this reddish brown color vanishes, that means we understand that the bromine reacts with the unsaturated molecule. Okay, so the product formed will be like this. Br. Now this is colorless. So initially this is colorless compound. Okay. So when we add a reddish brown color bromine, few drops. Okay, we call it bromine water. It's diluted one. Then we see that the color vanishes. That means the two bromine atoms will get inserted here and here. Okay. So the double bond turns into single bond. Right. So basically the reddish brown color vanishes. So this signifies that there is a presence of either double or triple bond. If all the bonds are single bond, that means this bromine water does not react. So that means the reddish brown color remains as it is. So the number 2 is aldehydes. So how to distinguish the aldehydes and other compounds, okay, non-aldehydes compounds. So for that we have two tests. One is Tollens test and another is filling test. But remember that Tollens test is given by every type of aldehydes, but filling test, aryl aldehydes does not give the filling test. So the Tollens test, right? So the Tollens test. Here we have aldehyde, suppose, and when it reacts with Tollens reagent, that is ammonical silver nitrate, 2 molecules of Ag NH3 twice plus 2 molecule of OH negative. So this forms, remember its product is it's a CH3 C double bond O negative plus 2 molecules of silver. Okay, so it will act as a silver mirror, it will form a silver mirror. Okay, plus 2 molecules of water plus 4 molecules of NH3. But this forms as a silver mirror. Okay. The main reaction is that we have to take these aldehydes in a test tube. Okay. Then we have to add freshly prepared ammonical silver nitrate. Okay, that is, we call it Tollens reagent. Okay, so everything is your Tollens reagent. So when you add this to the test tube, okay, and you have to heat it for some time, right? Then after some time you will notice that the silver mirror has been formed at the bottom of the test tubes. Okay, so this confirms the presence of aldehyde. Similarly, in case of filling test, okay, if we choose the same molecule, okay, and the filling reagent is your aqueous copper sulfate, okay, we call it filling A, and sodium potassium tartrate, so that is filling B, filling B. So we'll mix these two in the equal amount, then we'll mix with our aldehydes, okay. So this gives the reaction is this aldehydes plus 2CCU 2 plus, okay, plus 5. Okay, so in case of filling test, the reaction is like this. So when aldehydes react with this is mixture of filling A and filling B. Okay, so this gives sort of carboxylic acid and this copper Cu2O. Fine. So it forms a reddish brown precipitate. So if the reddish brown precipitate comes after adding the filling reagent, then we can say that is a aldehyde. Number 3 is alcohols. Okay, so to distinguish between the different types of alcohol, that is primary, secondary, and tertiary alcohol, we have to use the Lucas reagent. So that is the combination of zinc chloride and HCl. Now, in case of tertiary, that when we add the Lucas reagent, the turbidity appears immediately. In case of secondary alcohol, turbidity appears after some time. So it may be 5 minutes. So, but in case of primary alcohol, the turbidity appears only on heating. Okay, so we'll write that reaction. So Lucas reagent, then basically, okay, so this is turbid. So we can say that appears immediately. Turbidity appears immediately. So this is your tertiary alcohol. But in case of secondary alcohol, add the same reagent. So the product is which will be replaced by Cl. Here the turbidity appears after some time. That means maybe after 5 minutes. So that is our secondary alcohol. But if we have a primary alcohol like this, when you add the Lucas reagent, then the reaction takes place only on heating. Okay, so this appears only on heating. So turbidity, we can say that turbidity appears only on heating. Fine, so turbidity appears only on heating. So remember, in case of alcohols, if you have to distinguish primary, secondary and tertiary alcohol by a chemical reaction, that means we have to use Lucas reagent. So here, if by adding the Lucas reagent, turbidity appears immediately, then we can say that is a tertiary alcohol. If the turbidity appears after some time, around 5 minutes, so we can say that it is a secondary alcohol. If the turbidity do not appear, and if it appears only on heating, then we can say that is a primary alcohol. The next is iodoform test. This is one of the very important tests in organic chemistry. The compounds which has this format, we call it methyl ketone, okay, R. Remember this format, CH3 C double bond O, or it could be your secondary alcohol with this format, right? So CH3, CH here OH, or ethanol, even ethanol, which has some similar format, right? So these three type of compounds, so ethanol, the way go, and these two types of compounds. So this gives iodoform test. Okay. So in the iodoform test, normally we react this type of compounds with iodine and sodium hydroxide. So this forms the iodoform, which is yellow color precipitate, okay, which gives yellow color precipitate. Okay, we'll write the reaction now. CH3, CH2, okay, CH3, we'll just write C, we'll try with simple one. If we have this compound, okay, which has this group, we call it methyl ketone. Okay, so if then it reacts with your I2 and NaOH. Now it's supposed to give, so remember always just break this bond, okay, and this C, your carbon you, this forms your iodoform, this carbon, okay, so it's a CHI3, so it's yellow precipitate, plus, so whatever remains you have to start writing from this side, okay, so HC11O, so it's a HC11O, since we have used Na, right? So this is our iodoform reaction. So if we take another example, for if we have the compound like this, 2 C11O CH3, okay, so this is a ketone, but yeah, in this format here you can see here CH3, yeah. So if it has the compound like this, then it also gave iodoform reaction. So always remember your methyl ketone, this forms your iodoform, so it's a CHI3. Don't forget to write yellow PPT. Plus whatever remains you have to start writing from this side. So it's a CH3, CH2, CH2, okay, sorry, here is 2. CH3, so C11O, and it has a side product. Fine, so always remember, so this type. So if we have, I'll do the one more example. So if we have this one, 3CH, I'll take one thing CH3, so here comes H. So if we treat it with iodoform, instead of I2 NaOH, I2 plus NaOH, it can be also written as NaOI, remember. Okay, so when it reacts, actually it oxidizes to your C11O, okay, that is ketone, then the reaction takes place. So we just try the product. So it has the same configuration as CH3, so you can break either side. So I'm taking this side. So it's a CHI3, so it's yellow PPT. Plus, you have to start writing for other side. So it's a CH3, C11O, and A. Right? So the molecules which are in these formats will give the iodoform test. The next is carbonyl compounds, okay, which have the format of C double bond O. So both sides, it could be H or it could be R, right? So carbonyl. So how to distinguish carbonyl compounds and other compounds? So remember, the carbonyl compounds is present in aldehydes and ketone only, okay, not in carboxylic, not in ester. So carbonyl compound. So normally this gives your 2,4-DNP test, okay. So for that, suppose if we have a carbonyl group, okay, I'll write in this format. So it's a C11O group, right? So carbonyl group. So that means both the ketone and aldehyde will give this test, okay. So when it reacts with 2,4-DNP, so it's a 2,4-dinitrophenylhydrazine. Suppose this is NO2, nitro, here is hydrazine, okay, NH, NH2. It's hydrazine, so NO2. So it's a 1, 2, 3, 4. So 2, 4. 2, 4 dinitrophenyl hydrazine. Okay, so we call it 2, 4 DNP, dinitrophenyl hydrazine. So when any carbonyl compounds react with this 2,4-DNP derivative, then remember here H2 comes out and from here O comes out. So basically the water comes out. Okay. Then the product will be CH3 C double bond O. Okay. So it's a single bond H. Yeah. Then with double bond O, then double O will come out, then N will come. Okay. So double bond N. So double bond N. Here comes again HN. Then the benzene ring. Okay, with nitro group, 2 nitro group. 2. This forms a orange PPT, right? So this forms your orange color PPT. So whenever there is a carbonyl compound, when it reacts with 2,4-DNP, then the orange color precipitate forms. So this signifies that there is a presence of carbonyl group. So that means we can indicate that that compound may be aldehyde or ketone. The next is carboxylic acid. So how to distinguish between carboxylic acid and other organic molecules? So the main test is that we can do is sodium bicarbonate test. So here if we react carboxylic acid compounds with sodium bicarbonate, then the carbon dioxide gas will be released. So we can see the effervescence. So for example, if we have a carboxylic acid group like this, and it reacts with sodium bicarbonate, it forms CH3 C double bond O O Na plus CO2. Okay, so it's a gas plus water. So this forms brisk effervescence. Alright, so if by adding the sodium bicarbonate some bubble is coming out, then we can say that that compound is carboxylic acid. The next is primary, secondary and tertiary amine. So how to distinguish among primary, secondary and tertiary amine? So one of the tests is we call it Hinsberg test, in which we use the Hinsberg reagent. So that is benzene sulfonyl chloride. Okay, the structure is benzene as double bond Cl. So it says that when primary amines react with Hinsberg reagents, it forms a compound which is soluble in NaOH. Similarly, when secondary amine is reacts with Hinsberg reagent, it forms a compound which is insoluble in NaOH. And whereas in case of tertiary amine, it does not react with Hinsberg reagent. So in this way, we can distinguish between primary, secondary, and tertiary amine. The reaction is like this. So this is our primary amine. So this is primary amine. Primary, that means nitrogen has single branch, so it's primary amine. When it reacts with Hinsberg reagent, I'll write. Okay, so H will come out from here and Cl will come out here and it will add up. NH and here is S double bond O and benzene ring. Okay, so due to this H, which is this acidic, okay, it is soluble in NaOH. In NaOH. So second primary amine. So if we have a secondary amine like this, when it reacts with Hinsberg reagent, okay, again this H will come out and Cl will, so basically it gives HCl. So the compound is CH3 and here comes CH3, so H is coming out, so reacts with S. Okay, so it doesn't have H here, so it is insoluble in NaOH. So this is our secondary amine. But if we have a tertiary amine, so it's our tertiary amine. When we try to react with Hinsberg reagent, that is benzene sulfonyl chloride, okay, it doesn't react. So no reaction. No reaction. Since it does not have a H, so the chlorine cannot react, so it does no reaction. So in this way, we can distinguish between primary, secondary and tertiary amine. Okay, so in case of primary amine, it reacts with the benzene sulfonyl chloride, that's we call it Hinsberg reagent, to give a compound which is soluble in NaOH. In case of secondary amine, it reacts with Hinsberg reagent to form a compound which is insoluble in NaOH. And in case of tertiary amine, it does not react with Hinsberg reagent. The next test is we have a carbon-amine reaction or carbon-amine test. So this is normally given by only primary amine. So only primary amine give this test. Okay. In this test, we react primary amine with chloroform in the presence of alcoholic KOH. Okay, it gives isocyanate, which is very foul-smelling compound. Okay, so if the foul-smelling compound has been formed, then we can smell it and we can guess that isocyanate has been formed. So that means the given amine is our primary amine. If we write the reaction, so it will be like this: CnH2 plus chloroform CHCl3 plus 3 molecules of alcoholic KOH. So this forms RNC. Okay, so this is isocyanate. Isocyanate, foul-smelling. Okay, plus 3 KCl plus 3 molecules of water. Right, so if we have a primary amine, so this is primary amine. Why? Because nitrogen has single branch, alkyl branch. Okay, so it's a primary amine. When primary amine reacts with chloroform in the presence of alcoholic KOH, then isocyanate has been formed. So it's a foul-smelling. So only the remember primary amine gives this test. Next is the test for phenol. Okay, so to detect phenol, we can use azodite test. So in this test, we react phenol with benzene diazoxide salt. Okay, the reaction is like this. We need a benzene diazoxide salt. So it's N2. Okay, I'll write in other ways. NCl. So it's a plus here minus. So it's a benzene diazoxide chloride plus when we have a phenol OH. Okay, so this H. So here this Cl comes out and from here H comes out and this bond gets here attached here. So the product will be N double bond N. Okay, and double bond N, then this comes here and it's attached here. So at the para position of the phenol, so this forms your orange color dye. Okay, so when benzene diacetyl salt reacts with phenol, it forms orange color dye. So in that way we can detect the presence of phenol. The next is to distinguish between alkyl halide and aryl halide. Alkyl halide means which has CH3, CH2, suppose Cl. So it is sp3 carbon, okay, non-aromatic. But here aryl halide, we know it's a benzene and it's sp2 also. So Cl. So here you can say it's sp2, right? But sp2 of benzene ring. So it's aryl halide. So how to distinguish between this alkyl halide and aryl halide? So we know the main point is that this bond is very strong bond. It cannot be easily broken. Okay, it could be chloride or bromide. It could not be easily broken. But here this can be easily broken. So we can do the substitution reaction here. Then we will release this chloride. Then we try to react with the silver nitrate. So when silver chloride is formed, which is white in color, so in that way we can detect the presence of chloride or any other halides. Like other halides gives a different color, right? Only this will give the test. So we can say that is a silver nitrate test. So first thing is you have to react with this with NaOH, Cl. When it is treated with NaOH, whether that is SN1 or SN2, it doesn't matter, both will take the substitution reaction. Both will undergo the substitution reaction. If it is a primary, then it must be, sorry, it's 2 CH2OH, right? Plus we got NaCl. Now this, when this mixture is treated with AgNO3, now it won't react. Now this will react with this one. So AgCl plus NaNO3. Now this gives your white PPT. Okay, so AgCl is insoluble, so this gives white precipitate. So if the white precipitate forms, then we can say that is our alkyl halide.